Hey, welcome to Module 3, Lesson 6. This is your last lesson before our Module 3 test. And we've been dealing with fractions this entire module. All five of our first lessons had to do with fractions. And now for Lesson 6, we're going to throw in something random called inequalities. So, inequalities are like equations, except they don't have an equal sign. They have one of these signs right here. For the most part, there's one exception, but for the most part, you treat it exactly like an equation. So, before we kind of get into that, let's talk about what we got up here. It says integers to the left, I'm at this number line right here. Integers to the left of 0 are called negative integers, and integers to the right are called positive. The integer 0 is neither positive or negative. So I just kind of wanted to put this on here because we're going to have to number our number line. We're all good on this side here, but we need to remember that when it goes left of 0, you almost think of those numbers as going backwards. So just kind of keep that in mind. If you number this portion right here as like -1, -2, -3, -4, instead of it going backwards the way it is here, you will be counted off on a test question. Okay, so that's why this is here, to make sure we number that side of the number line in the correct order. So let's go into some definitions real quick. We haven't talked about an expression in a really long time. Hopefully that's been ingrained in you, that an expression has no equal sign. Okay, so for example, something like 3x plus 4. Then you have something called an equation. This has an equal sign. So for example, 3x plus 4 equals 10. Okay, there's the difference right there. And so then our last definition here is an inequality, and this is what we're going to be dealing with this whole lesson. Inequalities has one of the following signs. And we've done inequalities before, so those are either less than, greater than. These are kind of new ones, less than or equal to, or greater than or equal to. So, for example, 3x plus 4 is greater than 10. Okay, and this symbol right here can be any of those four, but that's the difference. Okay. So now let's get into what our signs mean. So if you use this one, it looks like it's pointing to all of these negative signs here. If you're using this as an arrow, this means less than. And then now when it has the less than symbol with a line under it, this means less than or equal to. So it includes that number, which this one does not include. I should probably put an X. This one does not include it. That one does include the number. So then these symbols here, use this as an arrow. It's pointing to the right. It's pointing to all of these positive numbers. So this is your greater than. And then likewise, when it has that bar under it, it is now greater than or equal to. So here we have brackets, and when we get into graphing these, our brackets go with these ones with the lines under it. So that's going to go with your greater than and equal to and less than and equal to. And I said those backwards, but it goes with your less than or equal to and your greater than or equal to. And then here we have, parentheses. And then these are going to be with your less than and greater than symbols. And it's also going to be with your infinities. Okay, and that's what this helpful hint's talking about. And then we have our infinity and our negative infinity. So on our number line, we have negative infinity down here, and we have infinity down here. And so this right here is going with these. So since we approach negative infinity and positive infinity, but it never arrives, so we place parentheses around it. So anytime you have infinity, you're always using parentheses, never the brackets with infinity. Okay, so information, let's try using it now. I'm not going to read this up here, but that's a good thing to read. And then you have some examples right here. Again, I'm not really going to go over too much. The only thing I'm going to kind of show you is like right here, you have the greater than or equal to. So it's pointing the way that it tells you to. And because it has that bar under it, it's got the bracket. And then it's shading the way that it's the way it's pointing. Same thing here, it's pointing this way, so my line is going this way, and because it has no line under it, the or equal to, it's got a parenthesis right here. So on this first one, x is less than 2, so this is pointing this way, so on 2 my graph is going that way. And because it has no symbol under it, doesn't have the or equal to on it, that means we have parentheses. That's literally it when you're graphing these. Okay, same thing here. This is pointing this way, right? So at -1, it is going this way. And because this one has a line under it, now this one gets a hard bracket. Now, notice that my line is going all the way to the end of that number line. That would be the same as if you like stopped it right here. Okay, because I have an arrow at the end of it, it means that it's going to keep going forever in that direction. So it doesn't matter where that arrow is, as long as you have an arrow at the end of that, right? Same thing here. I went all the way to the end. You can go all the way to the end if you want, but you've got to make sure you have an arrow signaling here and showing that that's going to keep going forever in that direction. Okay, so just kind of keep that in mind. Example 3, we're at -4 and it's pointing to the right. So at -4, pointing to the right, it's pointing the same way that's pointing. And because it has nothing underneath it, this gets a parenthesis. So now I have no number line, or no numbers on my number line. So here first, we need to figure out what this is. So let's make this into a mixed number. So 10 divided by 3. This means you have 3 on the outside, 10 over here. 3 goes into 10 3 times, multiply it back out, we get 9, subtracting, we get 1. So this is the same as x is greater than or equal to 3 from right here. My remainder, 1, and keep the same denominator, and 1/3. Okay. So let's number this thing. If this is between 3 and 4, right, it's more than 3 but not to 4, I need a 3 and a 4, and let's go a couple to each side. So let's go with a 5 and a 6 and a 2 and a 1. So because this one is the way that it is, it doesn't have to be perfect, but it means it's pointing this way. So my graph is pointing the same way this looks like. This line under it means that this is going to be a bracket. Okay, but you gotta convert that to a mixed number so you know what two numbers that's on your number line. Same thing here. -5/2. So let's go 2 into 5. 2 goes into 5 2 times, multiply it back to get 4, subtract, and we get 1. So this is the same as x is less than, it is negative, is less than 1, -2, and 1/2. We're keeping that 2 on the bottom. So now when I put this on the number line, we got to think, what two numbers are these in between? Since it's negative, it's more than -2.5, but it's not quite to -3. So it's in between these perfectly. Okay, notice on example 4, 2 was on the left, 3 was on the right, but now your 3 needs to be on the left, your 2 needs to be on the right, because now we're with the negative numbers. So we need a couple more to the left and to the right, so let's go with a -1 and 0, -4, -5. So when we graph this, it's in between my 2 and my 3, and this one's actually perfectly in between. Okay, I'm shading it to the left because that's the way this is pointing. And since this one has nothing underneath, this one's going to have a parenthesis. All right, so now we're going to use something called interval notation. It says, since there are infinite many such numbers, we cannot list all of the solutions of the inequality. And what we mean by that is, if you look here, okay, if you look at like this first one right here, it's starting at -1, it's hitting -2, -3, -4, but remember this arrow means it keeps going, right? So it hits -5, hits -6, it's eventually going to hit -7, -8, -9. Do you really want to list out all of those numbers? I bet you don't, because it's never going to stop, right? So because it's never going to stop, we don't want to write down all of those numbers. We use this interval notation. Again, you can read this. You've got some examples here. If you want to look at these examples, you can. I'm just going to go on to the next page and just start showing you rather than explaining these examples. But this page, these examples are here to help you if you need it. So on this page, they already have it shaded for me. So when you write this in interval notation, you always want to go from left to right. And you're not always going to use parentheses. So I'm going to do bracket parentheses. And I don't know what I want to do. Bracket parentheses left to right. And I'll do another parenthesis and bracket. Just because you could be using bracket or parentheses, it's not always parentheses or brackets or one or the other. In fact, they don't even have to match. This is actually really easy because you're just going to make this look exactly the way this looks right here. So, if you're going from left to right, the first thing you are encountering is an arrow. An arrow is pointing at what? My negative infinity. So we're starting here with negative infinity. Now we said on the very first page that my infinity or negative infinity always has parentheses. Every single time, does not matter about anything else. Always parentheses. So because we're starting with negative infinity, parentheses. Then, so we're going from left to right. We started with an arrow, which is pointing to negative infinity. As we keep going, it goes only to 0. Notice I have no shading past 0. It's not at 1, not at 2, not at anything else. It stops right here. So it's going to look exactly like that. It's going to have error 0. And because this has a bracket, so does this. Same thing on 7. Go from left to right. Where is this starting? It's starting right here at 3. You have nothing before 3, not 2, not 1, not 0, nothing shaded before. It's starting at 3. And because this has a parenthesis, this has a parenthesis as well. It matches the graph. And then it's going to keep going. You get an arrow. What's that arrow pointing to? Infinity. So it goes to infinity, and infinity always has a parenthesis. So now in example 8, we're doing both. We're going to graph this and write this in interval notation. So you've got x is less than or equal to negative 3. It's pointing to the left. So at negative 3, this needs to go to the left. It's got the line under it. The line under it means a bracket. So now in interval notation, go from left to right. We're starting with this arrow, which is pointing to negative infinity. So we have negative infinity. Infinity, whether it's positive or negative, always has a bracket. And then as you keep going, it stops right here at negative 3. It's got a bracket here, so it has a bracket here. Number 9, same thing. Oh, actually, it is the same thing, but before, I need to number this. So I've got negative 2, so I'm going to put negative 2 right here in the middle, and we need 2 to the left, 2 to the right. Just so you don't have to fill out, every single number, but you need a couple on each side. So we are on the negative side, so these numbers you need to think of are going backwards. So I've got negative 1 and 0, and then negative 3 and negative 4. Now we can graph. So this is pointing this way, so that's the way my graph is going. So at negative 2, we're going this way. It's got no line underneath, so that means parenthesis. So now to write this in interval notation, go from left to right. I first encounter where it starts, which is right here at negative 2. And because this has a parenthesis, it has a parenthesis in my interval notation. And then where's it ending? Well, it's got an arrow at the end, and it's pointing to where? My infinity symbol. So infinity, and that always gets a parenthesis. All right. Now 10 and 11 are going to give me different information, and I need to come up with the other two. So for example, it tells me to write the inequality. Your inequality is something like this right here. Your X, one of your 4 inequality symbols, and then your number. So I know I'm going to have X. I know it's going to be 1 since that's where my symbol is. So now we just have to figure out what symbol it needs. Is it less than, greater than, less than or equal to, or greater than or equal to? Well, it's pointing this way. So I know my symbol also needs to point that way. And because this is a bracket, that means there's a line underneath it. So that's my inequality. Write this in interval notation. You're going from left to right. What do you encounter when you first go from the left is this 1, and it's got a bracket, so does my interval notation. And then it ends with an arrow, and that arrow is pointing to my infinity. So parenthesis with that infinity. On 11, it gives me my interval notation, so I need to graph it first. So if it's got negative infinity, that means it's pointing there, and it's starting at a -3. So let's just start it here and make the arrow go this way. So we've got -3. And because we're on the negative side, this needs to go backwards. So -2, -1, -4, -5. And then it went to -3. This one has a parenthesis, so what's going to be on my graph is a parenthesis. Then when I write this in interval notation, I know I have an X to begin with. I know my solution, -3, will be in there. So now which symbol do I need? Well, it's pointing to the less than sign, so I need my symbol to point the same way. And because this is a parenthesis, it means you have nothing underneath. So that is it. All right, objective D, we're actually going to start solving these, then graphing and writing it in interval notation. So these are the same steps that we've dealt with before. Okay, LCD, distributive property, combine like terms, number on one side, terms on the other side, usual multiplication property, which is usually division. Everything's the same except for this one change. It says, don't forget that if both sides of an inequality are multiplied or divided by a negative number, then the direction of the inequality symbol must be reversed. If you multiply or divide by a negative number, you've got to flip your inequality symbol. Now I'm pretty sure, let me see. Yeah, the first couple ones don't have anything to do with this new rule. So I'm going to come back and show you guys this whenever we need it. But this is the only difference, and you need to memorize this. So memorize it, but forget it for now. This first one, solve this. So to get x by itself, you're just going to subtract your 5. So we're going to bring down x, or less than or equal to. And 3 minus 5 is -2. So that is me solving it. Now let's graph it, and then we'll write it in interval notation. This is a 3-part thing. So this has no number on it. So I need -2 somewhere in the middle. And then we need 2 to the left, 2 to the right, but it's negative, so go backwards. So -1, 0, -3, -4. This symbol here is pointing to the negative side, so we're going to the negative side. You have a bar underneath, so it means this needs brackets. So now write this in interval notation. So from left to right, I first encounter this arrow, which is pointing to the negative infinity. And any type of infinity always has parentheses. And then where is this ending? This is ending at -2. If it's got a bracket here, we've got a bracket here. This one on B looks simple, but be careful. To get x by itself, the opposite of subtracting 4 is to add 4. Those cancel out. I get 1 is less than x. Now, when you have an equation, this is perfect. I don't care if it's 1 equals x or x equals 1, right? Those both mean the exact same thing. The same is technically true with inequalities, but because I need that symbol to kind of tell me which way to shade things, it is really important that your x is first. So here, when I flip my x and my 1, you also have to flip this symbol to go the other way as well. If you look at it here, it's pointing to the 1. Now it is still pointing to the 1. If you flip your x and your number, you've got to flip your symbol as well. So this right here is my final answer. And this is what this is talking about. That if you flip your things, you also have to flip your symbols, right? So it shows you right here that 2 is greater than 0. But notice here, when they flip that 0 and the 2, they also have to flip the symbol. So now 0 is less than 2. Okay, and they did the same thing here and here as well. You need that symbol first. You need your variable first. Number second. It matters with inequalities. So I get 1. And let's go ahead and number a number line. So I've got 1 here in the middle. So 2 and 3, 0, -1. So I'm going to start at 1. Now this is pointing to this way. See how this is pointing the other way? You've got to flip it so it's pointing the right way. So at 1, it's going to the right. You have no symbol under it, no bar under it, so it means you've got a parentheses here. So now this, in interval notation, it's starting right here at that -1, which has a parenthesis, and it's pointing at the end at infinity, and infinity always gets parentheses as well. On C, solve, you've got x, 5x is greater than or equal to 20. So the opposite of multiplying by 5 is to divide by 5. So I get x is greater than or equal to 4. So on our number line here, we have 4 in the middle, 5 and 6, 3 and 2. Use your thing as an arrow. It's pointing this way. So that means I need to go to the right as well. It's got the bar under it, so that means bracket, not parentheses. So in interval notation, it starts right here with 4, which has a bracket, and it's pointing to the infinity, which is always parentheses. Okay, here's where my new rule is coming into play. On D, same concept. You got negative 5x divided by negative 5x is greater than or equal to 20. So the only difference between D right here, and C is that now I have a negative 5. Everything else is the exact same. So when I divide both sides by a negative 5, this is where that new rule comes in. When I multiply or divide by a negative number, the direction of the inequality sign must be reversed. So now, my negative 5 and negative 5 cancel. I'm left with x. 20 divided by negative 5 is negative 4. But because I divided by a negative number, instead of this being greater than or equal to, is now less than or equal to. When you divide or multiply by a negative number, your inequality symbol is reversed. So now here, we've got negative 4, negative 3, negative 2, negative 5, negative 6. Use the symbol. It's going this way. Oh. So we're going this way. It's got the bar under it. So that means bracket. So if you kind of notice here, in the original, it was pointing this way, but now we're going in the opposite direction. Gotta flip it. And so I guess, I didn't remember I put this here again. We multiplied or divided by a negative number, so the inequality symbol reversed. Write this in interval notation. We first come across an arrow pointing to my negative infinity. Negative infinity is with parentheses, and then it goes to negative 4 with a bracket. Now, D and E can sometimes be very easily confused with each other. On this one, on E, to get x by itself, I need to divide by 5. However, when I divide by 5 and I get x and I get a negative 4, just like I got a negative 4 here, I am not flipping my symbol because I am dividing by a positive 5. It does not matter that this top one here is negative. I am still not dividing by a negative number. So because I am dividing by a positive 5, honestly, just like I did right here, you don't change the symbol. So this symbol here stays exactly the way it was. Okay, so it doesn't matter that this is negative. I'm dividing by a positive number. So number your line. Negative 4, negative 3, negative 2, negative 5, negative 6. This is pointing this way, so I'm going to go the same way. You've got a line underneath, so that means a bracket. So it starts at -4 with a bracket, and it's pointing to your infinity, which is always with a parenthesis. Now F and G are multiple step ones. Just be on the lookout for your new exception to that rule. So to get x by itself on F, opposite of adding 7 is to subtract it. So I've got -4x is greater than let's subtract 7 from both sides, sorry. -4x is greater than -16. So then we're going to divide by -4. Those cancel. So I've got x, -16 divided by -4 is 4. Do I need to flip my symbol here? Yes, we do, because we divided by this negative number. This symbol needs to go the other way. So on our graph, four, use this arrow, it's pointing to the left, so we're going to the left. It's got nothing underneath it, so we've got parentheses. So then in interval notation, we first come across this arrow, which is pointing to the negative infinity. And then it ends with this 4 and a parenthesis. Okay, and our last example on this page, first we need to distribute. We haven't distributed in a little while. So I've got 8 is less than 2 times x is 2x. 2 times 8. Nope, 2 times 4 is 8, sorry. Get x by itself. Subtract your 8 over. Opposite of adding 8 is to subtract it. Cancels on one side. It sort of cancels on the other side, but we need a number there. So we'll have 0. So 0 is less than 2x. Don't let that 0 confuse you or make you stop. Divide by 2. 0 divided by 2 is 0. And then we're left with x. My number and my variable are opposite. So we need to take this and rewrite it where you have x on the left, 0 on the right. If I flip my variable and number, I also need to flip the symbol here. So this is my true answer here. So now when we graph this, we've got 0, 1, 2, -1, -2. Okay, now my symbol is pointing this way to the right. So I'm going to the right. And it's got nothing underneath, so we have parentheses. If you don't flip it, you're going to be shading it the wrong way according to that symbol and that arrow. So you've got to flip it over. And then interval notation, it starts at 0. And it's pointing to infinity, which always gets parentheses. All right, and last page, we spent last lecture doing problems like these. You can do these in 2 steps. If you want to do them in 2 steps, you can. I'm going to do these both in one step. One, because I'm short on time, this video is getting long, and two, it's just the easier way to do it. If you like the two-step way, go watch last video on last lesson, lesson 5, and you can do it in 2 steps. But the easiest thing to do when you have a fraction being multiplied by your variable is to multiply by the reciprocal. Your reciprocal is just flipping that fraction. So I'm going to multiply this by negative 3 over 2. I just took this fraction, instead of it being 2 over 3, it's 3 over 2. My 3's cancel, my 2's cancel, and you can even think about your negatives cancel. You're left with a y. We'll talk about that symbol here in a minute. What I do to one side, I must also do to the other. So I'm going to multiply this side by a negative 3 over 2. Multiply straight across or cross reduce. I'm going to cross reduce real quick. So these two are both divisible by 2. 8 divided by 2 is 4. 2 divided by 2 is 1. So 4 times negative 3 gives me negative 12. And because I multiplied by a negative number, we have to flip this symbol as well. Multiplying or dividing by a negative number, you have to flip your symbol. So there's my answer. So now let's graph. I've got negative 12, negative 11, negative 10, negative 13, negative 14. Use your symbol. Your symbol's pointing this way. So I am shading this way. It's got a bar underneath. That means bracket. So it starts at negative 12 with a bracket. It's pointing to infinity, which always gets parentheses. Okay, this one's the same thing. I'm going to multiply by the reciprocal. So this becomes negative 4 over 3 times that by negative 4 over 3. 4's cancel, 3's cancel, even my negatives cancel. So I'm left with y. Over here, cross reduce. This way, you can reduce them both by 3. So 9 divided by 3 is 3. 3 divided by 3 is 1. So 3 times negative 4 is negative 12. So didn't mean to make that happen, but that's okay. And then do you need to flip your symbol? Well, because we multiplied by a negative, yes, the symbol here needs to flip as well. So my answer is this. So graph needs to look the same as far as the number line goes. This one is pointing to the left though. Use this as a symbol. So this one needs to be shaded the other way. And because this has no bar under it, this one will have parentheses. So pointing to the negative infinity, you've got negative infinity, comma, to the negative 12 with also parentheses. Okay. Now this last part. Here you have compound inequalities. So this first one here, basically if you've got negative 3 and 1, that's what your graph is going to be in between. So when we label these, I'm going to go negative 4, negative 3, negative 2, negative 1, 0, 1, 2. Going to be in between this one and this one since that's what my things are here. Now this first one is perfect, right? That's the correct order. My problem is that, oops, I guess that works, is that this one here is now flipped. So this would be x -3, flip this symbol to go flip this symbol to go this way here. So when you graph, you've got -3 needs to be going this way. You've got 1, which needs to be going this way. So you can see it's just this portion right here in between. And then just use the symbols. You've got parentheses here and parentheses here. So when you write this in interval notation, it looks exactly like that. Parentheses, -3, 2, 1, parentheses. Okay, same thing here. This one's fine. But this one, you need to switch. So this one, x -4, this symbol needs to flip to this way here. So this one is going to be in between -4 and 2. Okay, my -4 is pointing this way. So from -4, it needs to go this way. My 2 is pointing this way. So it needs to go here. They're going to meet each other. So it's in between these two. Then use your symbols. Here, we're going to have a parentheses. Here, we're going to have a bracket. So now in interval notation, this is -4 with parentheses, comma, 2 with a bracket. All right, guys, this was a long one. Pause this video, rewind it as you need to. Let me know if you have any questions.